Hello guys, today we'll be learning about the process that is filtration. So filtration is basically the separation process which separates the solid matter and the fluid using a filter media. Usually in the filter media we can take the activated carbon or slow sand, okay? And the process of filtration basically is a process which will remove the particles from suspension in water, and this basically takes place by a number of mechanisms that includes the straining, flocculation, sedimentation, and the surface capture. Okay, so basically this is a physical process. Okay, and for example the filtration process can be, you can most commonly use in our household is the making tea. So while preparing a tea, usually we use a filter or a sieve that is basically used to separate or segregate the tea leaves from the water. Okay, so shortly we will be seeing uh, the device which is present in our laboratory, which is the automated water filtration unit, okay, which is made from, from the brand name electronic Venita. Okay, so usually this system is used to, clean, or you can say the purify the water that is coming from the primary clarifier or the primary unit. So usually here we are going to do a lot of experiments, but in this one we are going to restrict our experiment. Would be, we would be cleansing or removing the chloride ion from the water using the activated carbon column, or you can say the activated carbon filter. Okay, so hello guys, today we are going to learn about the device that is called automated water filtration unit. Okay, so we have the control unit here, okay, from where we are going to run the equipment, and these are the filtration column, which is the first one is the slow sand, and this is the activated carbon. Now Mr. Gulrez will demonstrate how to work on this equipment. So Mr.
turn it on from here.
Okay.
Power on. And this is the main control panel.
Okay. Can you please open the panel?
There is a key on the top.
Okay. Okay. Then.
And we have to open it from here. Open the panel from here. Now
Okay.
it's open. You have to open the both sides from here and from here.
Okay.
Once you open the panel,
Okay.
so you have to turn it on from this is the power button.
Okay.
Power button. You have to turn it on from here.
Okay.
So there are the three different pumps. You will see the G1, G2, G3. G2 and G3 for the additives.
Okay.
You want to add the additives, but we are not going to add the additives from these two pumps.
Okay. So,
G2 and G3.
so these are called disinfecting agents, right?
Yes.
Okay.
So these pumps are connected with the D4 and D5, but we are not going to use additives.
Okay, fine.
But our main concern is we have to use this pump G1, which is the water supply pump. So we have to put the water in the pump in the tanks. We have to
D2.
put this one.
D1 or D2?
We have to look which one we are going to use.
We are basically going to use the activated carbon one. Okay.
If we are using this one, we have to fill it out this tank. Okay, but these tanks are interconnected. If we are using both of these, the tanks are interconnected from the down.
Okay.
So in our case, we will use the D2, and we have to check on the back side. We have to check all the valves must be closed. If one of the valves in the back side is open, the water can go outside from the pump. So if you look at the V6 and V18,
they are all closed.
These are closed.
Okay.
These are already closed. So we have to fill out this tank, and this is, if you look on the connection, this is connected here.
Okay.
Here. You can see here, the water can go here.
Okay.
So if we close this one,
okay,
the water cannot go in this one.
Okay, fine.
But if we are using both of them, we have to open the valve V1. But now, no need to open the valve. We will close the valve because this is connected with the pump. If you look at this one, this should be closed because this is the sampling valve. You can take the sample from here. It's only for the sampling.
Okay.
And don't open it full. Only open a little bit.
Okay.
So when you turn on the pump, this G1 from the panels, when you will turn on the pump G1, the water will go out from the flow meter. This is flow transmitter. It transmits the flow. It's called the flow meter. So don't put it more than 500.
Okay.
Okay. This is the bypass valve. It should be like this, always like this.
Okay.
If you open fully, the pump will not. It will work at a very high rate.
Okay.
So in order to control it, you have to put it like
so
this.
be partially.
Partially, yes.
Okay.
Partially. Always it should be partially.
Okay.
If you fully open it,
Okay.
then it will be very high flow.
Okay.
The pump flow will be very high.
Okay.
So in order to maintain like 500, maximum 500, 400 to 500, you can partially pull it out and you can play with this. If the flow is very high, you can move it a little bit. This one.
Okay.
This is closed. This side is closed because this is broken. We are not using this one.
Okay.
This is closed. It means
Okay.
it's not. Now this is not working. This
Okay.
is closed.
Okay.
You can see the line. This line is also closed.
Okay.
So the water, if you look at this one, look at this one, this connection, the water will go from here, from here, this closed. So the water will go all the way from here, and this one is also closed.
Okay,
If
fine.
you
So it
get
will
the
not go to
B
this
line is
column.
Closed.
Okay.
This one you need to open it.
Okay.
Open it. Okay.
Okay.
So the water will go from there.
Okay.
The water is already going from here, from the top,
Okay.
and this is closed.
Okay.
Okay, so this one is also, if you look at this one, this is open. So first you have to close this one in the beginning, because otherwise the water will flow from that one and go quickly down there. So you have to close it in the beginning. Once you turn on the pump, you can open this one so the water can flow back in that tank, in that tank.
Okay. Okay.
So this one is measuring the pressure in the outlet. This one is measuring the pressure on top one.
The inlet.
So yes. So there is a pressure knob up there. If the pressure is very high, this is pressure safety valve on the top. You can see this
PSV.
safety valve.
Okay.
So it's controlling the pressure. If the
Okay.
pressure is very high, you see the knob.
Okay.
You can release it a little bit.
Okay.
If the pressure is very high here. Okay. So the pressure shouldn't, if you can see the red sign here, the pressure shouldn't go above 10 bar.
Okay.
This is the maximum pressure it should attain. If it is going above that one, it means the equipment is in danger. So you have to open a valve and release the pressure a little bit.
Okay.
Okay, same like this for this one.
Okay.
It shouldn't go more than 10 bar.
Okay.
Okay, so that's it. That's everything about this equipment.
Now we need to add water, the water. Okay, that has to be treated by the activated carbon filter. Okay, so what we will do, we'll add a specific amount of sodium chloride. Okay, so the water will be rich in chloride ions, and the water will go through this column, and then we will take the readings for every 5 minutes. Okay, so now guys, we will add around 20 gram of NaCl. Okay, just stir it up. 20 gram of NaCl and 50 liters of the water. So this is a little more, just a pinch. Okay, just more. Okay. Now we will add this salt to this bucket and mix it thoroughly. Okay, and then we will transfer the water around 50 liters to the tank, raw water tank. Now we will transfer this water which is having chloride ions. So the idea is to prepare the water which is having the pseudo water which is having a lot of chloride ions. Just transfer it. So we are transferring the water to the bucket. We will fill the tank till the around 50 liters, and then we will try to treat the water. Now start the equipment, please, Mr. Gulrez. What do you have switch on?
Turn on the motor, but it's not working. What's
Okay.
wrong with it?
Okay. So the now water has started to flow. Okay, you can see.
We can, from the set point, this is showing the liter per hour. We can set the flow from here.
Okay.
So this is on the automatic. If you put from here, we can set it to 500. 500.
So it is 500 liters per hour.
Liter per hour, yes.
Okay.
Okay. So let me check it.
Yeah, the water is flowing.
Yes, right now.
Okay. So it is still here now.
Yes,
It's flowing to
coming
the
here.
column. Then, and how to take the water? Yes. We have to take the initial water, Mr. Goodress.
Sorry?
We have to take the initial water for analysis. The initial water. Okay.
Initial water?
Initial water means at time 0.
Yes, we can take the sample. You mean the
Yeah,
sample?
this sample.
Yeah, we can take the sample from here.
Okay. After every 5 or 10 minutes, we will take the sample and then we will analyze for chloride. So please take the first sample. The first sample around 50 ml. Okay, 50 ml, please. Yeah. Yes, 50 ml.
Huh?
50 ml. 50 ml.
From this side?
No. From this.
From this one?
Yes. Okay. Yes, add this here. Now add a few drop of indicator. This is potassium chromate. Okay, and this is my titrant, which is silver nitrate. Okay.
Only 2 drops?
Yeah, few drops.
Yep.
Yeah, enough to just get a color. Okay, now we need to initialize this. This is already in my YouTube channel, that how we measure the chloride ion using titratometric method. Okay. We need to add slowly and slowly. Okay, the color should be, the end point should be brick red color around. So we'll add slowly and slowly so that the color change.
How much?
It depends on the amount of chloride ion it has. Okay, slowly.
What is that? What is that inside that one?
First it will be like it will become turbid. Okay, a little bit, then it will change. The color should be like this.
And what's inside?
This is silver nitrate. This is a titrant. So they consumed around 33.05 ml of the titrant. So this is my first reading. The second sample around 50 ml.
One more thing I want to tell you.
Yeah.
Now you can see the flow of water. Flow water.
Yeah.
Because there is the air stuck inside
Okay.
this channel before, you know.
Okay.
I've opened this valve. Now I
Okay.
close this valve because we are not working on this side because
Okay.
It's going from the top and passing through all the way down.
Okay.
So if you
I
look
mean,
at
like
this
we
side-
can open this also or close this. Doesn't matter.
Yeah, we have to close it now.
Okay,
Now we have to close this valve because we don't need that one because the water is coming from the top.
Okay.
You can see it's coming from the top.
Okay.
It's passing through all this.
So both are closed.
Yes, it's closed. Yes.
Both.
This one is closed. This one is closed.
Okay.
Now look at the flow. Now it's almost 500 because we set it here.
Okay.
In the beginning we set it 500 set point.
Okay.
Set point liter per hour is 500.
Okay.
So it's attaining that point now. See.
Okay.
In the beginning it was low. Now it's attaining that 500. You know.
Okay. Okay.
Now you can see it. Now it's 500. So at 500 you can reduce a little bit. If you open more, it's going up. So
Yes.
you have to reduce
Okay.
it a little bit like this. Okay. See?
Okay.
Now the flow is very good.
Okay.
If you look at this one.
Okay. We'll transfer this and then add a few drop of indicator, and then we will start to add the titrant slowly and slowly, very slowly. Okay. Ideally, we should add a bead and transfer this to the hot plate. Okay. Add slowly. Okay. Let me add, and then you can shake it. Okay. Slowly, don't be fast, so that we don't miss the end point. Yes, little more. Slowly. Give it to me. You don't have to change the direction of the knob. Can you shake it? No. Yes. Can you shake it more? Little more.
Yes.
Okay. Little more.
Yes. No, it's okay.
So there is a drop in the consumption of the titrant. So which is around 24.36. Add slowly and slowly. So we'll just take 2 more samples because our column is showing very good removal, or you can say good adsorption of the pollutant. Make sure you don't turn the knob in the other direction. Okay, slowly. Okay, can you give the knob to me slowly? You can just shake it.
Slowly now. Now it's done. Almost done. Slowly, please.
Okay, can you just?
Yes, done.
So the third reading is also dropped. Now this is our 4th sample. So we will just do the analysis for one more sample. Slowly. Slowly. Can you just hold on? Just go this way. Okay. Can you show me? Yes. Can you just shake it, please? Okay. Okay, just shake it. So this is also a drop. This is around 21.88. Simultaneously, this is the last 5th sample. We are stopping at 5th sample, and then also we will see how to calculate the chloride ion in the water, because now we are just noting down the values of how much amount of titrant is consumed to regenerate or do the backwashing for the activated carbon. You can say the column or the filters. This is around 21. It's consumed around 21 ml of the titrant. The reading here is constant. Now we will do the calculations for the all 5 samples. So the first one, you can see the formula is the volume of titrant consumed. This is normality of the titrant, this is which is 0.014, and so we will put the values, just feed the values, and then we'll find out. So for the first one, it is 33.05, and this is 0.014, and this is, and the volume of sample was 50. So you can see that in the beginning it was 328.05 ppm or milligram per liter of the chloride ion. So immediately see it dropped to 241, then 227, and this is a big drop from 328 to 208.